Hi engineers, and welcome to 2.1.1, Part A, which is called Centroids. We're going to talk today about what a centroid is and why it's important for engineers to understand where the center of mass is. We're going to learn how to calculate the center of mass for very simple objects. I'm going to show you a couple of examples of where centroids would be important. So let's get started. The first place I want to take you to is Elon Musk. When I recorded this, Elon Musk is he's building a rocket that's going to send people to Mars, and he's testing it currently. So this is a rocket that they sent up. It's called SN. I think that this is number 8 because it's their 8th test. Center of mass, or centroid, is if you take an object, where is its center of mass located? If you have a simple object like a rectangle, the center of mass is going to be right in the center. Like you take left and right. But you've got a complex object like this rocket. Maybe it's heavier towards the end where the rocket motors are. And maybe as you're burning fuel, the centroid is actually moving. But it's important to know where the center of mass is because when this rocket's landing, it falls to Earth sideways, and then it's going to burn, and it's going to flip itself upright. It's going to pivot around its center of mass. So this thing burns, and this whole thing is pivoting around where the center of mass is, and it's somewhere towards the bottom end because the engines are pretty heavy. So they're working right now on how to burn this at just the right time to get it pointed straight up and down so that they can land. So the centroid is important specifically in aerospace to get this thing, when you rotate something, it's going to spin on its centroid. A friend of mine is an engineer for NASA, and he was doing things with the Orion space capsule. The Orion space capsule is the thing that's going to take humans to the moon here in the next decade. So knowing where the centroid is here, because if the center of mass is too high, here they're testing a splashdown. I think this is in Florida. Setting this thing, letting it go to simulate what splashdown is like, and does it right itself. See, it's sideways, and then it comes right side up. They're really testing to see if this thing is stable inside of water. So where the centroid, if your centroid's too high, then the thing's gonna flip upside down. So understanding where that centroid is really important to engineers, because when you start turning or applying a torque to it, it's going to spin on that centroid. Let's get started with the formal presentation. The centroid is known as an object's center of gravity. We label it like this. So if you ever see this symbol, that cross with these two, like a BMW symbol, this represents the center of gravity. And on a weight here, that's where the centroid would be located. If the centroid's over here, more force is going to exert, and then this thing is going to tip to the side. If you're applying your force on the centroid. What do we use it for in statics? Theoretical calculations regarding the interaction of forces, and just a lot of fancy words for when you apply a force, you want to know if the thing turns or not. Here's an I-beam, and knowing where the center of mass, or the centroid, is, we're going to look at what's called a cross-section. So we're going to turn this thing and look down the end, and it makes like the letter I. And the centroid would be right in the center. Some things are symmetrical. So if it's symmetrical, like a circle, the centroid is going to lie on the line of symmetry. So like if you were to draw a line right down the middle of this thing, the centroid's going to be somewhere on that line. It's probably going to be closer to the bottom because there's more mass at the bottom. We'll learn how to tell exactly where it is coming up shortly. In a rectangle, maybe this has multiple lines of symmetry. So the centroid is going to exist where those lines cross. And in a circle, there's lots of lines of symmetry, and the centroid is exactly right in the center of that shape. How to find, this is, if you have a rectangle, these are the centroid, we use this X bar. X bar represents the X value of the centroid. Y bar is the y value of the centroid. And it's really just, if this thing is 10 by 5, the centroid, the x is going to be 5, and the y value is going to be 2.5. It's just the base divided by 2 and the height divided by 2. If you've got a rectangle, just divide the height by 2, divide the base by 2. Simple as that. A triangle is going to be a little bit different. It's 1/3. You take whatever the base is, divide by 3, and that's the x value. And you take whatever the height is, divide that by 3, and that's the centroid. The centroid, you could literally put your finger and you could spin that triangle right on that centroid, and everything would be balanced. It would spin perfectly and balanced if you were to use that centroid, center of mass. A semicircle, you know that it's right here. So whatever the base is, divide by 2, and then it's 4r divided by 3 pi if you're going to find the y value. So the x value is, again, half of the base, but the y value is this 4r over 3 pi. And so, for instance, they're giving you an example here with the radius is 2. 4 times 2 divided by 3 pi. You have to make sure that you put parentheses if you're going to do this on your calculator. Now, what if you have a complicated shape? Whoa! These are really, if I was looking at this in high school, this would totally be intimidating. And I want to try to explain what these letters and things mean. So don't get overwhelmed by all the symbols here. All this is saying is this means add. So you're going to add up. Well, maybe I'll talk about the x. I mean, they're all the same, you can see. But this means add. I don't want to talk about z because we're not doing anything in 3 dimensions. You're going to add, and all of the x values of the centroids. All the x values of the individual, that's what the I stands for, is individual. And then A means area. And that's all these things mean. So you're going to multiply the x value of the centroid, multiply by the area of that centroid, and then add them all up, and then you're going to add up all of the areas. So this is if you have a complex shape. If you have something that's complicated, and I'll go through an example right here. Here's a complex shape. What we're going to do is we're going to break this complex shape into more manageable shapes. Like we've got a rectangle, a square, and a triangle. So we're going to find the centroid of each of these, which is not that complicated to do. And we'll find the areas of each of these shapes, which again, not that complicated to do. And then we're going to start multiplying and adding. That's all these words back here. When you go back a slide, we're just going to find x and y values of the centroids, find the areas, and then we're going to do a little bit of dividing. So let's just take a refresher course on areas in case we didn't know. So a square is just the side, this squared, hence the name square. A rectangle is the width times the height. A circle, this is one that people forget all the time. It's pi r squared. And then the area of a triangle is the base times height divided by 2. 1/2 base times height. So let's go back to this quote-unquote complex shape, and let's go through how to find the centroid of this complex shape. So step 1 is find the centroid of each individual shape. So here's my first centroid, and it's going to be half the base. Since the base is 3, the x is going to be 1.5, and this thing is 6 high, 3. Here's my next one. So this is going to be 1.5, but you're going to add 3 to it. So this is going to be, the x value is going to be 4.5, and then it's 3, so that's 1.5. And then a triangle, if you remember back, it's a third. Since this is 3 wide, it's only 1. So it's 3 plus 1, so its x value is 4. And then it's 3 plus another 1, so 4, 4. So here are my centroids for each of my shapes. Find the centroids of each of the shapes. Step 2, find all the areas. So I'm going to circle my areas, or maybe I'll do it in blue to kind of keep it separated. So this area is 3 times 6. So this area is 18. This area is 3 times 3, which is 9. And this area is 1/2 base times height, which is going to be 4.5. So now what we're going to do is we're going to plug it in to that crazy equation where it was like x bar. We're going to add up all the x values of the individual centroids, multiply by the area of the individuals, and then we're going to add up all of the areas of the individuals. So let's do that. So we're going to take the x value. So the first one is 1.5. 1.5 times the area, and the area was 18. Now we're going to add. That's what this symbol right here is. Add to it the next one. So my next x value is 4.5 times the area, and the area of that was 9. Add the next x value, 4, times its area of 4.5. Now we add up all the areas. So my first area was 18, my next area was 9, and my last area is 4.5. So now you pull out your calculator, and you take 1.5 times 18, and you do all of that, and you end up with 85.5. And then 9 plus 18 plus 4.5 is going to be equal to 31.5. And then you divide those things, and you get 2.71. So there is one big centroid that is the centroid of this entire thing, this entire crazy complex shape. And the x value is 2.71. We're going to do the exact same thing to find the y value of that x, of that large centroid. So, to find the y value, it's the same thing, except this time we're going to do the y values of all of them. So this isn't going to be an x, it's going to be a y when I do that equation. So I take the y value, which is 3, and I multiply by the area, 18. Here's my next y value, 1.5, times the area, which was 9. My next y value, 4, times the area, 4.5. Divide that by all the areas, 18 plus 9 plus 4.5. And believe it or not, you end up with the exact same number. It's not always going to do that, but this shape is symmetric. It is symmetric along this line, right down the diagonal. So you know it's going to be, the x and y values are going to be 2.71 and 2.71 because this shape is symmetric along that. So if you were to drill a hole 2.71 inches over, 2.71 inches up, you could spin this whole thing on your finger right there. Kind of a complicated equation, but not that bad when it comes to actually applying it. So again, you just find all the x values, find all the y values, and then the x value multiplied by the area, x value multiplied by the area, x value multiplied by the area, and then add up all of the areas. ends up with a fraction, and there you go. There's an alternative solution. Instead of using 3, like we did before, how we broke this into 3 separate pieces, now watch this. This is kind of clever. I'm going to use this piece. Here's piece number 1 is a square, but piece number 2 is going to be a ghost triangle. I'm going to use negative area. So I can do this exact same problem, but I can take away the subtracted way. I can take away something and treat it as a negative area. And let me show you how I would do that. It's the exact same process where we add up all the x of the individuals and then multiply by the area of the individuals divided by adding up all the individual areas. So same steps. So step 1, you're going to find the centroids. Shape number 1 is a square. So it's going to be right in the center. So 3, 3. Shape number 2 is a triangle. And remember, it's going to be a third of the way. So this distance right here is 1. So that means that the x value is 5 from the left and 5 from the bottom. So here's the x and y values of that centroid. Remember, it's a third, right? A third of that is 1. So 6 minus 1 is 5. Step 2 is the areas. The area of this one is 6 times 6, which is 36. The area of this one, remember, the secret, it's a negative area. So it's 3 times 3, 1/2 of that. So this area is negative 4.5. Step 3, plug it into the equation. So that equation here is this. We're going to add them all up. So take the x variable, 3, times the area, 36. Add to it the x, 5, times the area, negative 4.5. Now I'm going to add up all the areas. 36 plus negative 4.5. And believe it or not, see how this is, it's one less term, it's one less thing, it's much easier math to do. Still comes out to 2.71. If I do the y, it's the exact same thing. Take the y variable, 3, times the area, 36. Add to it the y variable, 5, times the area, negative 4.5, divided by, add up the areas. 336 plus negative 4.5. It also comes out to 2.71. So here's another way to find the centroid of an object using what's called the subtractive method. You can add a negative area, a ghost area, if you will. Common structural elements. Beams are just assemblies of complex shapes. So if you want to find the centroid of this L beam, you break it into 2 rectangles. If you have a C, you could break that into 3 rectangles and find the centroid of that. If you have a box, that's kind of symmetric, so the centroid is going to be right in the center. An I-beam, again, that's symmetric, so my centroid is going to be right in the center. When we start pushing and pulling on things, like a beam, this is a beam suspended between 2 triangles, and we're going to push down on this, you're going to find that some of these things on the top are what we call compression. The red represents things getting squeezed together, and the blue represents things getting pulled apart, tension. Different materials have different properties when it comes to compression and tension, and we're going to get to that in a few lessons. So just suffice to say that the centroid is kind of where this neutral plane is, and then things above it are going to be in compression, things below it are going to be in tension. Wow, guys and girls, I know this was a lot. I know it. And I know that when you see this, it freaks so many of you out. It freaks me out. But I'm excited that I can decode it with you. Take your time. Remember the steps. Find the centroid of each of your shapes. Find your areas. And then you're going to plug those X and Y components into each of your equations. So you're going to take the X value of the centroid, multiply by its area, and then add each one together. Have a good day. If you have any questions, please let me know.